Good morning, afternoon, wherever you are. My name is David Levy-Faur, and we are in the webinar series on the metrics of regulation. Glad to have you. I will stop here, but before I stop and give the floor to my co-host, Dr. Nir Kosti, I will invite you to subscribe to our YouTube channel. So thank you so much, and Nir, the floor is yours.
Yes, thank you very much, David. We are very happy to welcome you today to our new session in the Metrics of Regulation webinar series. The series focus on exploring innovative ways to measure and quantify regulation. So far, we've covered issues such as policy portfolios, regulatory burden, the grammar of regulation, the regulatory process. And one key question we usually ask is where this challenge of measurement is heading, how it will enable us to do things or to achieve new tasks we could haven't done before. And today we are driving into one of the most promising advancement in this area, which is the use of large language models, LLMs, which open new doors in regulatory studies and regulatory analysis. And we are very happy and very fortunate to have with us Arpit Gupta today to discuss how LLMs have allowed to study US zoning codes. Welcome, Arpit, and thank you for joining us. And before giving you the floor, I will briefly introduce you. So Arpit joined New York University Stern School of Business as an assistant professor of finance in 2016. Arpit's research interests focus on using large data sets to understand default dynamics in household finance, real estate, and corporate finance. So Arpit, thank you very much, and the floor is yours.
Thank you very much for the kind introduction. It's a real pleasure to be here in this series, which is really focused exactly on the question at hand today. So let me briefly kind of motivate the project we're trying to do here and kind of connect it, I guess, to your overall objective that this is sort of a topic I've wanted to study for many years, which is the subject of housing regulation. And we think that housing regulation is extremely important for all sorts of different outcomes, not just in the US, but in many other countries. And the challenge has always been that these housing regulations live in documents that are hundreds of pages long and vary enormously across every single municipality. So we have thousands, tens of thousands of municipalities, each of which have their own document for housing regulation. And the complexity of that task of trying to synthesize and understand regulatory bodies that are this, large, is challenging and beyond the scope of a human. And so there have been prior attempts that have tried to tackle this question in various ways. And the key argument that we're going to try to advance in our project is large language models have, to a substantial extent, made progress in being able to scalably and accurately codify regulations of that nature so as to create structured data sets out of vast unstructured textual corpus that we're going to apply to housing regulation, but I think really have very broad applications to regulation overall. So I'm very excited about the prospect of being able to use large language models to accurately code up regulations in all sorts of different areas. And I think one of the key contributions we're trying to make with this project is to show you how. How is it that you're going to be able to, all of you are going to be able to do that and apply these tools in different domains? Because if you just start and take a housing regulatory document or take whatever regulatory document you're interested in and you just upload it to ChatGPT, it's not going to necessarily be very accurate. Maybe you've tried to do that yourself and you probably notice it hallucinates, it makes errors, et cetera, et cetera. And so there is a lot of work that we've done to figure out how to take the messy, unstructured task of transcribing regulations and make it more accurate, make it really scalable and work. And that's going to be the whole focus of the talk today. So this is, super excited about this project. It's joint work with Alex Bartek, who's at Urbana-Champaign, and Dan Milo, who's a phenomenal PhD student at NYU Stern. All right. So I've kind of motivated this already. We want to understand housing regulation. We think it's really important. And it's really hard to study because we have all these different zoning codes and documents. And so what we're going to basically put forward is a general purpose technology which works to systematically parse, understand at scale all these regulatory documents. And we term this process generative regulatory measurement. It's generative because we're like generative AI, we're creating something new. We're creating a new data set out of this. It's regulatory measurement because we're obviously trying to measure the content of regulations. And then we're going to do a bunch of stuff here in this paper to measure the accuracy and validity of this process. The bottom line is we think we're something like 96% accurate with binary questions. So yes, no questions. We measure those against a hand-coded data set. So the way to measure validity and all these things, right, is to have sort of humans transcribe and go through it by hand, measure the accuracy of an LLM relative to that kind of core validity data set. So we think we're 96% accurate on binary questions. And with continuous questions where we have more of a range, we have a correlation of about 0.87 between the continuous questions and ground truth in our data set. We take that from this Massachusetts Pioneer Institute data. That's the hand classified data set. And we do a bunch of other validation here. So it's pretty accurate. It's certainly accurate enough for me as a researcher to be happy with using for all sorts of purposes. Is it accurate enough for a developer to decide what to build in what area? Probably not. But it's sort of remarkable the extent to which I think these tools have already are already able to produce these very highly accurate classifications of data sets, and obviously further improvements and refinements are only going to push these numbers up further. Okay, so let's just kind of get into what data set are we going to be using, what's the general methodology, and of course, importantly, how do we validate whether these classifications are really accurate. And the first thing I really just want to emphasize in terms of the benefits of using large language models compared to human classifications is the cost. So we've done a lot of thinking about how do we measure and benchmark the cost of this regulatory transcription. And the key thing to kind of take away is, like, as you increase scale, the LLM gets really, really good in terms of its cost advantage. So what I'm showing you here is, the x-axis here is the number of municipalities that we're trying to understand. We have two sets of questions here, 15 questions, kind of a minimal set, or 50 questions, like a larger set of questions that you want to ask of this regulatory data set. And then I'm contrasting what we think a human costs versus what an LLM costs. So the human costs are based on kind of our own personal experience, sort of hiring law students and things like that to kind of read through these codes. And so, it's not surprising it sort of scales linearly. There's not a lot of economies of scale in having humans read through documents. You just kind of have to pay whatever is the hourly cost. And so if you're going to, let's say you want to go through about 3,000 documents, let's say you want to ask 15 questions, we think a human's going to cost roughly $100,000 to do that. Because you've got 3,000 municipalities. You need humans to read through all of those. You need them to answer responses to 15 questions that you're asking about these documents. We benchmark that about $100,000. If you want to ask 50 questions, that cost escalates to $350,000. And we're going to basically scale this up not to even 3,000, but 6,000 municipalities that are going to cover a majority of the United States. So at that scale, it's really just cost prohibitive to try to get a human to do it. Now, by contrast, we have here what the LLM costs. Now, if you're under, let's say 500 or 1,000 municipalities, something like that, it's actually cheaper to use a human because there are a lot of fixed costs. But the overall cost advantage for an LLM is, we think we can get basically the whole data set done for, let's say, $15,000, $40-ish thousand. So we're able to kind of construct this national housing regulatory index across thousands and thousands of municipalities and just really do it very cheaply at scale. Where do those costs, where do those residual costs that we have come from? Really, it's still human costs. There are still a lot of embedded human costs in this process because you have to basically prepare the questions, prepare the text of the documents. There's a lot of processing that's going to have to take place that humans will do to get the data set ready for the LLM to work with, and then to work with the LLM in kind of matching everything. The actual API cost for all this is actually pretty small. So that of our final budget, that is, less than $5,000 is the actual LLM expense. The residual is still like mostly human cost. So somewhat ironically, this is one of being like one of the most human intensive projects I've ever done. Even though like 99% of the work is still being done by the LLM, because there's still enough associated human complementarities, which is, I guess, good for our future as researchers. Okay, but the really important point here, which is that LLMs offer this enormous cost scaling advantages when working with large textual regulatory text. And that's going to open up a whole range of different analyses that right now are simply too cost prohibitive for humans to even think about. Okay, so what are some other pros and cons of this LLM approach? Well, we kind of talked about the first one. It's a lot cheaper. It's a lot faster, obviously, of course, than humans. It would take God knows how long to get humans to read through all of this. But there are all other sort of subtle advantages too, I think. If I were to try to get humans to code through 6,000, municipal codes, probably what I'd find is different humans disagree on interpretation. And so if I can't get one person to read through 3,000 or 6,000 documents, I need to get multiple humans. And, what do I do when multiple humans disagree on the interpretation of a given block of text? Often, you're going to get multiple people to read the same thing again and again. One question here from the chat, how can these regulatory measures support the reduction in disparities and improve well-being? I think that kind of speaks to what are the broader potentials opened up by having this technology deployed at scale. And I do think it's potentially quite important, both for our ability to, I'm starting out here from the ability of the researcher to understand what the regulation is, so that we can then do research on the implications of these regulatory texts on outcomes in the world. So that's the sort of first step of trying to understand what's the impact of regulations. And down the road, you can imagine that there's a lot of other implications for how regulations actually get written. If in fact, people can have access to these tools. And I think you're already starting to see that, because as people file regulatory documents, they have to obviously write down all this text, and that's either in the law of making mode or how companies and firms respond to these regulations and create their documents too. And more of that is being, for better or worse, being outsourced to LLMs. So this is all kind of on the advantages side of it so far, but there are a lot of problems too. That's going to be a key focus. So the biggest one is that LLM lies. So it doesn't always tell the truth. They have this problem of hallucinations. And so that's going to be the key question actually in this project, is to try to figure out how often that happens. How often do we have an accurate versus an inaccurate classification? And how do we actually measure that? So we're going to do, again, a lot of this training and validation against human classified data to really measure and quantify the scope of that problem. The other really big challenge is LLMs really have a limited effective window that they can kind of understand. Now, this is being really tested in ongoing model development for these tools. But as of right now, most LLMs that you kind of work with, they're not really sized appropriately for the scope of the text that we're feeding into it. You're feeding a 300-page document, it doesn't, it's a needle in the haystack problem for it to actually find the right words, the right sentence in that document that answers the question you have in mind. And so we're going to use this technology that's very common in computer science called RAG, or retrieval augmented generation, which we think does a very nice job of actually solving the needle in the haystack problem and delivering to the LLM the correct block of text necessary to answer a question. So this is all pretty vague. So let me just give you a concrete example to illustrate how this process is going to work. So we're going to look here at Arlington, Massachusetts. So this is a municipality in the state of Massachusetts. And the whole reason we're doing this project at this municipal level is that's where zoning housing regulations are set by in the United States. Every city, every municipality controls their own housing regulations. That's why we have thousands and thousands and tens of thousands of them. And the question that we want to answer is whether this zoning ordinance has any mandates or incentives for the development of affordable units. This is a really important feature of the regulatory environment, whether you are mandating or otherwise incentivizing, specifically cheaper housing units, because it represents either an important tax or important subsidy for the creation of these housing units. We want to know whether the municipality does it. So what we're going to do is take this ordinance, again, it's pretty long, we're going to chunk it up into bits. So we're going to break it up into different subsections. So here, for example, are two subsections in this document. There's one section on affordable housing requirements specifically. That's going to be a relevant block of text. And then there's another one here on parking spaces. So that's kind of an irrelevant block of text for actually answering this specific question. Very relevant for other questions. Then what we do is take all these blocks of text and put it into something that's called an embedding model. So an embedding is a function that maps a text corpus into a vector. And the nature of these embedding functions are to preserve the meaning of the text in the vector space. So the simplest possible embedding you can imagine is a function that maps, and just kind of maps the text corpus into a vector and just counts how many of each word in the English language are included in that base reference text corpus. So if I have, 3 these or, 2 mentions of include, et cetera, there'll be a 3 and a 2 under that vector assignment. And so that will be a vector that's the length of the English language, and you just count how many times a certain word frequency shows up. That's a very long vector. And so what they figured out is how to shorten these vectors substantially. So we have like a 3,000 dimensional vector, and it is mapping all of these text documents into these vectors. And the idea is that two vectors that are more similar to closer to each other in vector space also mean similar things in textual space. So the benefit of this is we can now take this whole textual document, map it into vectors, and then now I'm plotting what that vector space looks like. And the really cool thing is that if you look at, again, we have these different chunks of text, so every circle is like a little chunk of text. Cool thing is that the chunks of text are similar to each other within each section of the code. There's no mechanical aspect about this. It's just showing you that the regulatory document, when you embed it, preserves closely the meaning of different sections of different articles. And so they're all kind of neatly laid out, here. Another question here from Nir, LLM. So is a broad term. We have a specific model we use. So we do a lot of kind of cross-testing validation. I'll probably get to a little bit later with different models. But everything I'm showing you here so far is with GPT 4.0. So with kind of the latest frontier version of GPT, that's the one that we've done the most work with. But we've done some stuff with like Cloud and open source versions as well, like Llama 3, et cetera, et cetera. There are some differences we find between them. But the general approach here that I'm talking about can work with, you can swap in any LLM model for that. So the star here is the question that we wanted to answer. And again, that's this affordable housing requirement. And you can see that there's going to be a bunch of text chunks here that are close to it, i.e. there are blocks of text that seem to be similar in this embedding space to the question that we want to actually answer. And you can see, dig in a little bit even closer here. You can see there are a couple of sections on affordable housing requirements that are very close to the question. So that's good, because we're asking a question about affordable housing. It seems like there's some sections of the text on affordable housing that line up very similarly here. There's some other random stuff that kind of seems sort of similar. And so basically what this process is going to do for us is identify the narrower parts of the document that seem to be most closely related to actually answering the question that we're trying to solve. This is going to solve the needle in the haystack problem, because now instead of looking through a 300-page document, we have very small sub-chunks of text that this model has identified as being relevant to answer the question at hand. So then we provide the LLM with additional background information. So we sort of tell it what inclusionary zoning is, what affordable housing requirements are. We give it, various provisos and, legal interpretation. This is, again, a nice feature of working with these LLMs in a regulatory context, is you can provide it whatever is the necessary context or background to understand a particular document in a way that's going to be constant across all interpretations of this document in different calls, right? Very different from a human, which, who knows what a different human might interpret or think about, or across humans. And here's what we get in the end. So does this zoning, require mandates or incentives for affordable housing units? Yes and yes. It says this ordinance requires that 15% of residential units in new projects be affordable. Gives us the part of the code that requires that. It tells us that if you do have certain criteria, then I think there's also some sort of subsidy, some sort of like benefit you get here as well. And so this town has basically mandates and incentives for the development of affordable units. The answer to the question is yes. And we have the specific citations and background necessary to support the conclusion of why the regulation is a certain way. So I've taken a very complex and thorny unstructured data set, this giant housing regulation form, and classified that into a structured data product, which is a yes or no classification on this question with supporting textual information to validate and back up that claim. So that's basically the idea here in a nutshell. What we're doing. So having kind of sketched out the broad process of doing this, let's talk a little bit about how accurate we think we can get with this question. So the way we do this accuracy test is by looking at this existing hand classification, which was done by the Pioneer Institute in Massachusetts. So they had basically gotten humans and they went through 187 municipalities before they ran out of their budget. And they give us a whole list of questions that they asked of these regulations and hand classifications for these regulations. And so we're looking at those questions that they asked, we're looking at their classifications, and then asking how well does the LLM do at reproducing that exact same answer. So for the question we just looked at, these kind of affordable incentives, we get that 100% accurate. So all the time that humans say a certain thing, we kind of agree with them. We also do pretty well on whether or not multifamily is allowed. And on average across these binary questions so these yes or no questions are about 96% accurate. Then across continuous questions, we ask things like the minimum lot size. So like how large does a housing lot have to be? We have a numeric number for that one. So that we compare and then correlate how much does the human transcribed number associate with the LLM. And so that's like a 0.92 correlation. On average across these continuous questions, it's like a 0.87. So we seem to be doing a pretty good job at measuring both binary questions as well as continuous questions. And we've done a lot of additional, checking, validation, looking through all this stuff, comparing it to other data sets, et cetera, to try to understand and validate where these are coming from. I don't know if I have the model comparison for you, but we also compared it. One of many things we did is compare ChatGPT to Claude to other ones. We get the best accuracy with GPT 4.0, but that's also partly because we've structured a whole process providing the guidance and et cetera, with GPT in mind. So if you were to work from the ground up from another LLM, it's probably going to be pretty good too. Okay, so I think that's the broad overview of what we're doing. To give you a little bit more context and background into how we were able to further build up this model, we had to sort of train it a little bit. So training in this context means that we have so we took the 187 municipalities, we broke them up, some that we left for a leave out testing sample, that the accuracy numbers I showed you came from that, and others we use for training. So what that means is we try running it once, we see it gets whether it works or not, and we figure out what we need to do in order to get a more accurate response, more accurate answer on this testing sample. And then by comparing it against this out of sample validation sample that's not used for the training, we avoid overfitting, right? And so there are a number of aspects of that. So So this is, more in the weeds, but I figured you would be interested in knowing the exact details. So one is prompt engineering. So that is trying to frame and tell the LLM what role basically to sort of assume. So we sort of tell it to behave kind of like a sort of legal, kind of interpreter. We provide it with, I showed you an example of some question-specific background and assumptions that you need to answer every specific question. And then we had to do a little bit of multi-step processing on more complicated questions. That entailed two things. One is taking complex questions and breaking them into subparts. So if it's a sort of compound phrase, ask different parts of it separately. And in some cases, if it's just asking it to double check itself. So it gives you an answer, and you're like, really? And then it's like, no, I lied. And so this somehow just asking it a second time sort of improves the improves the validity of these things. So these are all just like incremental steps that further improve the accuracy of the final response. Just some examples of what those kind of look like. I mentioned minimum lot sizes as an important regulation we want to answer, right? So again, a minimum lot size requirement in the U.S. is a regulatory requirement that your house has to sit on a plot of land that is of a sufficient size. It's a really important regulation because it therefore results in a minimum, unit of land that can be used for different plots. And so we ask it the minimum lot size. And here, the challenge is that to actually answer this question requires going through a whole bunch of different parts of the code. So we break it up into a few parts. First, we ask it to list all the districts. So there are different districts that each have different lot size requirements. So we get all the list of different districts. And then we ask, okay, in each of these districts, what is the lot size requirement in that district? That gives us a set of all the lot size requirements across all the districts. And then to create one number for the whole municipality, we just take the smallest of all of those. That's the min lot size. So that tells us the smallest possible lot size that would be possible within the municipality. So another challenge, for example, comes with these ADUs. These are accessory dwelling units. Another huge part of U.S. housing regulation, whether or not to allow these kind of like smaller, sometimes they're called like in-law suites, kind of like smaller housing units located on a property. Huge question whether or not to allow them or not. And so we look through the document. We ask, are these things allowed or not? And the challenge is, no could mean a couple of different things. It could mean that the code says, no, you cannot do this, or it could just mean there's nothing explicitly banning it or allowing it in the document. And in that case, you have to have some sort of legal interpretation of mind of can you do it or not if it doesn't really mention it. And so if the LLM says no, we sort of double check it by kind of looking, doing some keyword searches. So like if you don't allow accessory dwelling units, and accessory dwelling units are mentioned in the text corpus, well, that sort of tells us, yes, they're explicitly mentioned and they're banned. Versus if they're not mentioned at all in the text and the LLM says no, that tells us what's probably going on here is there's just no mention of them whatsoever in the document. So these kinds of things are just examples of how to do this sort of multi-step approach. So some other other kind of issues here. We kind of talked about kind of taking all these questions, putting together in kind of one standard sort of document here to sort of ultimately harmonize this into one kind of convenient thing. We used previous regulatory questions that have already been asked to kind of have the standardized approach. This allows us to then back check and compare against what other studies had already done. We allow the model to say, I don't know sometimes. It's unfortunate, but sometimes the law is not always 100% clear. So we have to tolerate some degree of ambiguity in the law itself. It's actually kind of an interesting outcome by itself, whether the LLM can't really figure out whether it's allowed or not. And then we sort of, this sort of prompting process is necessary to sort of deal with some of these exceptions and edge cases that sort of pop up along the way. All right. So that was kind of the bulk of what I wanted to talk about, which is how we actually constructed the data set, the process we use, which again, I hope is a fairly general approach that can be used to tackle comparable questions in multiple different domains. Of course, we're specifically interested in housing regulation So I just want to walk you very briefly through what we found as a result of all this work. You can kind of see where it actually leads to, and then I'll leave some time at the end for Q&A. So one of the first things that we sort of found, so we're organizing our data discovery here in 5 facts. So the first fact that we're kind of looking at the data is that a lot of the housing production in the United States basically happens outside of incorporated areas entirely. So incorporated areas refer to municipalities that have these zoning regulations, and those are colored here basically in green. So it's kind of like the centers of cities. And then red is unincorporated. So it's outside the sort of control of these housing regulations entirely. It's under the purview of other county regulations. And the first sort of fact is that a lot of housing development, we see that because the higher the density is, the darker the color, is happening in these unincorporated areas. So for example, if you look at like Atlanta here, again, green is all the incorporated areas within cities. Red is sort of like outside the control of city boundaries. And there's lots of stuff happening in red outside. So these are kind of greenfield fringes of metropolitan areas. And in general, when we kind of look across municipalities, we see that if, areas that have high incorporation of land have lower housing growth, areas that are like not very incorporated, i.e. they're in this sort of unincorporated fringe area, they have much higher housing growth. That's really where housing growth is happening in the United States, outside of zoning areas kind of entirely. And there's a really large fraction of overall housing production that's happening in these areas, even though they're far from jobs, far from amenities, they're not much population, they're not great places to live in, but they don't have the same level of housing regulation, and that's where housing production is therefore being pushed to. Then what we do is try to look at a lot of these different regulations, and we just sort of, second fact here is just emphasizing that these regulations function to limit density. So how do they limit density? Well, one question, for example, is whether multifamily housing is even allowed. So in a lot of U.S. municipalities, you cannot build a apartment building. So we see that across 5% of U.S. municipalities, it is illegal to build a multifamily housing unit anywhere in the municipality. There are also limitations around, apartments above commercial units, i.e. mixed-use buildings, whether you can convert housing into multifamily, whether you can have a townhouse, so that's illegal in 20% of municipalities, or whether you can have these accessory dwelling units. So those are still illegal in roughly 70% of municipalities. So these are restrictions on building multifamily housing, mixed-use building, these attached single-family housing units and ADUs. These are all broadly limited across the United States, and that also is a function of lowering the density, residential density that is allowed in the United States. Even when you can build a multifamily unit, there's a lot of land use regulations that limit where. So we did an analysis here for 31 large municipalities. This covers 18 million people. And we see that 41% of the land area in these large cities, so that includes Chicago, San Diego, San Francisco, et cetera, 41% of the land area in these cities is exclusively zoned for single-family housing. That means you cannot build an apartment building on that land either. You can only build an apartment building on 31% of the land area. So when you limit this much the ability to build up, that's going to have obvious consequences for our ability to, for housing supply, ability to accommodate people, et cetera, et cetera. When we look at single family areas, so these are the single family zoned areas, we see that these minimum lot size requirements kick in. And so 66% of these areas have a minimum lot size requirement that's above 5,000 square feet. 17% have one over 10,000 and 7% above half an acre. What does that mean to, how can you sort of put that into relevance? Well, a house in the US is on average about 2,000 square foot of floor space. You can roughly divide by 3 if you want to convert that into meters. So typical house, 2,000 square foot of floor space, and like 20% of areas require that house to sit on 10,000 square feet of land. So that's all going to be lawns and gardens and things. And that has a massive density reduction function if you are requiring the house to be so, the lot to be so large relative to how houses usually are. We find that these minimum lot size requirements are really high in suburban areas around cities. So these are all sort of exclusionary suburban areas where they're using these sort of large lot sizes to sort of increase the income requirements of people who can live there, because you have to be kind of rich to buy all this land, and so that ensures a certain degree of socioeconomic segregation. And so this is really common in these suburbs around large major cities. And that's particularly the case in the Northeast. So it turns out the Northeast has these really large suburban minimum lot size requirements, much more so than actually the whole rest of the country, especially in the suburban areas. Then we take all of our housing regulations and then we combine them into principal components. So we want to understand what are the main associations and drivers of housing regulation. And we find sort of two key principal components that drive a lot of the variation in our housing regulation. So there's PC1, PC2. And first principal component here is something that winds up being a sort of demand driver. So the first principal component of housing regulations here sort of shows up in the sort of top right quadrant meaning high house prices and high units permitted. So basically, in areas that have high house prices, but also are building a lot, you see a lot of this first principal component. That kind of looks like a demand shifter. So what does that mean a little bit more concretely? Well, these are areas that are more democratic. These are areas that are producing a little bit more housing, and they have, let me show you some of these regulations that fit into them. Things like affordable housing mandates that we talked about. So think of that as like a tax that you're able to impose on housing units. You have to put some of those and set aside for affordable purposes. That's like a tax you can only get away with when demand is high. We have other sort of mandates and other things going on there, things like age-restricted housing, and a lot of process requirements, things like public hearing requirements, waiting times for development review, these sort of process regulatory requirements. These are high in these high demand areas. And we kind of interpret all that as sort of an indication you're sort of extracting some surplus or value in a high demand environment. And either you're redistributing it to people or it's just being sort of sucked up in delays and waits and things like that. But there's a bunch of regulation that is sort of associated more with these high demand environments. These are more democratic areas, et cetera. Then the second principal component here of housing regulation, it really is stuff like the minimum lot size requirements. And these are basically things that enforce quantity requirements to limit the influx of low-income people. And so these are areas that have much less affordable housing, defined as housing that can fit within 30% of your income. So these are expensive homes. These are not homes that are affordable to low-income households. They actually have pretty good test scores. So the exclusion of low-income people associates with a population that is able to access sort of these sort of high-quality schools, and they've sort of kicked out all the poor people to accessing those areas. We do a lot of other correlations and associations of these sort of principal components, and sort of trying to back up our interpretation of one principal component being about demand, the other being about kind of excluding supply by curtailing the left tail of kind of housing quality. And so kind of put that all together in one picture. This is kind of a map of sort of, we've got the city center here, we've got suburbs, and then we've got this unincorporated area outside of housing. And so the idea is that housing regulation is very complex. It's very convoluted in the city center. And that's sort of about extracting some of the value in this high demand city center. Then we go to the suburbs, and that's where we see this exclusionary zoning pattern of trying to keep out low-income people. And then finally, we go out to this unincorporated area outside of all housing regulations, and there it's more like a competitive market. There's far lower regulation. So kind of interpreting some of these facts that we put in sort of context of a monocentric city idea. So hope you enjoyed the talk. I think the main idea that we're trying to convey is that there is a rapidly improving ability to measure the content of regulations. We put forward a methodology called generative regulatory measurement, which uses large language models and RAG and to allow for the systematic interpretation of very large text corpuses. Because this is a cost-effective and scalable and accurate approach, we think this can work in a lot of different areas. to accurately classify all sorts of different texts. And our code and data is publicly available at this GitHub site. So you can go there, check out our code, check out our data, apply what we've done to whatever context you're interested in. And I hope that this is a resource that proves valuable for other researchers who are interested in applying these tools and techniques to their own regulatory context that you're interested in yourself. We use this generated data to sort of find that housing seems to have important consequences for housing production, housing density through these two channels of rent extraction and exclusion. So kind of went through those facts, and there's a lot of other stuff that we want to look at in the future. We're hoping to do a lot more with this data set and other related questions. We want to look further in time to kind of measure how these regulations have changed. We'd like to better use tools of computer science and things to understand the complexity of housing regulation, understand this ambiguity part. And there's, I think, a lot of interesting inference questions, like how exactly should your standard errors work when the data is sort of made up in the first place. So I think there's a fantastic research frontier here for people to further dig into, both specifically within housing regulation itself, as well as in kind of regulation more broadly. So thank you all very much, and happy to answer any more questions you have.
May I?
Yes, okay. Thank you very much, Arpit, for this really interesting talk and presentation. I see two questions here, one by Rachel and one by Nir. So Rachel, please.
If that's for me?
Yeah.
Okay, thanks very much. Now, when the initiators invited us all to look at how LLMs can be used for analysis of regulations, I joined without knowing that the topic is smack within my international and national expertise. So I'm sure that many others did not know ADUs and exclusionary zoning and so on. So thanks very much for being my precise cup of tea. And wow, you've opened great horizons for my own and my research team's further research. If you'd like, we could communicate outside this forum. I'm the founder. Let me just introduce myself. First, I'm a member of the Israel Academy of Sciences, National Academy of Sciences, and I'm the founder of the International Academic Association on Planning, Law, and Property. And the entire theme is, planning law in U.S. language, we land use law regulation is all regulation, as you showed. And so the International Academic Association that I established, we deal so much with regulation, and my own claim to fame is international comparative on a large scale. I'd love to talk to you.
Yeah, happy to chat. And one of the various items in our future to-do list is to see how these regulations vary across country. Because
you're going to have lots of trouble. Even there is no set of international terms. You make a lot of mistakes. So it's decades of study that allow me to do that. But yes, the horizon is in international comparative analysis. It gives scale, proportion, and capacity to criticize.
Okay, thank you very much, Rachel. And Nir, please, can open your microphone.
Yes, thank you. I'm currently studying the regulation of higher education in Israel, and I got approximately 500 papers of decision of the Council of Higher Education in Israel. And some people told me, yeah, just throw it to ChatGPT, and ask him question, and he'll tell you everything, etc., etc. So I would like to hear from you again briefly about the process. How can you trust him? How can you be sure he's telling you the truth? And what kind of questions or guidance you put to ChatGPT to get the right, the correct answers for your question?
Yeah, well, first of all, I'm not sure about the gender of of the artificial intelligence, but
Arpit, let me ask this question, and I have a follow-up question or connected question, in the sense that what are the learning costs and what are the processes that leads you towards having those capacities to do the analysis? So maybe start from the basic, from your experience, and who was your mentor, etc.
I don't know if I've had a specific mentor on this project. Honestly, it's like a topic I've always wanted to study, so I've kind of been germinating on it in some sense for years. But we kind of picked this all up ourselves, reading the sort of relevant computer science literature and so on. But the general approach, I think, starts. All right, can you still hear me?
Yes.
So the general approach starts with knowing what questions you want to ask. So that's sort of first step. Figuring out, like, even if you had humans, what would you ask the document? Then, the way that this research typically goes is you have your validation set. So you have some humans go through, answer those questions, and then ideally split that up into some training and testing sample. And then you use your testing sample, first of all, and then you figure out how to get the LLM to answer those questions correct. And so this RAG methodology is one way to reduce the complexity of the document if that's necessary. Of course, maybe the document is small enough that you can just put the whole thing in, but RAG is something that can help kind of shorten the context window to get to the specific blocks of text to answer the question. And then you sort of see how accurate you are on the testing sample. You figure out what you need to, why is it getting it wrong? What do I need to do to reprompt it or add more context, et cetera, to get a higher accuracy? And then you deploy it on that training sample. And that sort of tells you, like, in an out of sample way, how accurate you think the model is. And so the costs are really human costs associated with that whole iterative process of trying something. Okay, it didn't work for this reason. I need to add this context. Okay, I need this prompt. I need this information, and further improving it until the point that you're sort of happy enough with the progress. The way the private industry works is they sort of keep going further. They sort of like really figure out, how do we deal with all the edge cases? How do we like make sure it's 100% accurate? Because that's the accuracy level you want if you want to sell this product. I'm a researcher. I can kind of live with some degree of error, so I don't need it to be 100% accurate, as long as it still seems pretty darn accurate to me.
Okay, thank you. Any other question?
I see Ari asked something about, can people use it to ask specific questions about their house? Right now, no, but I think eventually, yes. I think eventually that function can be baked in.
Okay, I want to jump in. I have two questions. The first is about, so you portrayed cycles, what happens in the cities. I mean, the regulations in the cities, they affect also the regulations later in the suburbs, and then the third cycle about the areas which are exempt of any sort of binding regulations, if I got it right. And my question, I mean, first of all, is what do you think drives it? What is it? Is it interest group politics? What are the political dynamics beyond it? And then the second question is also more methodological, about, first of all, what was your main challenge here? What do you think? I mean, thinking about it, about the whole process, what was the main challenge or the most difficult challenge along the way? And then if you can please go in the same line you just started about some best practices or considerations or recommendations if we have like a project in our mind.
Answer in reverse order. I think one of the biggest challenges is getting the documents because they're spread out all over the place. So we had to go through a whole process just to accumulate and get the regulatory texts and documents in the first place. Then we found there were just a series of iterative improvements we could layer on one on top of the other to keep pushing up the accuracy of the approach. And so for people looking at other contexts, I think often the hardest stuff is just sourcing the documents and then having that kind of human cooperative work to like work with the LLM and figure out why is it getting it wrong, what do we need to change, et cetera, et cetera. And that part isn't hard so much as time intensive. You have to figure out what it's doing, try things, and then keep working and playing with it. As far as the like sort of basic facts, my view is the key driver is the fact in the US we don't have school finance equalization. What that means is if I have a municipality, so I'm one of these units, I fund my schools with the taxes I raise internally from my own municipality. You can kind of saw on the map, a lot of these are pretty small municipalities, actually. It's very different from how it works most of the rest of the world, actually, where schools are funded in some equal per pupil formula. But this actually creates like very stark incentives for who lives in an area. Because first of all, these are the peoples that are going to go to the school. And second of all, it's the spending that's going to sustain the school itself. So what you have in these suburbs is, first of all, they kind of structure themselves to be a lot smaller. Then they, have these exclusionary tools to, kind of ration out low-income people. And that enables really high per pupil spending on schools, enables really high school quality. And then like, you don't see the low-income people there. So that sort of explains, I think, this sort of ring of these exclusionary suburbs around these dense cities. And, they go to the city for work, but they live in these suburbs and then they send their kids to school. This whole pattern, again, by the way, you don't see in other countries. Like rich people in Buenos Aires, they live in the center of the city. Rich people in Madrid, they live in the center of the city. It's not how it works in the US. Rich people do not actually, on average, live in the center of the city. They live in these suburbs. And they do it, I think, because they can then send their kids to those local schools and the whole system is set up for high opportunity there. The city itself can't really do that. You can't really kick out that many people out of the whole city itself, and so it doesn't really regulate on that dimension. Instead, the fact that it's sort of like a high demand environment, there's not that many competitors. So again, the suburb like is competing with every other suburb. They're sort of not that differentiated product, but the city has this huge monopoly power, and it leverages that monopoly power to engage in rent extraction in these different dimensions. And so that it's kind of the interplay of those two forces, sort of rent extraction and kind of exclusion, and kind of ultimately tying that to like how schools are funded. But I think sort of accounts for not just these housing regulations, but the sort of general structure of U.S. cities and kind of the who lives where in U.S. cities, which is very different from who lives where in cities in the rest of the world.
Thank you. That's very interesting. I do have one question about the interface or the training with the chat or with the LLMs. So I mean, usually when training humans, it takes a while, it takes several cycles, some discussions when using or upgrading or changing, amending the prompt, the design of the prompt. Do you have any tips for that? What is actually happening there in this phase?
I'm honestly not sure I'm the best person to ask about that. There are a ton of computer scientists and LLM people that probably work a lot more intensely with that sort of prompt management side of things. Our paper has some discussion of some of the choices you have. So like one big one is like the role that you sort of assign the LLM. So if you sort of tell it to behave a certain way, it sort of adopts the characteristics of the role that you assign it. So you want to figure out what would be a relevant role in your context, generally some sort of expert or something like that. There's a choice also of temperature, which is sort of like how variable the whole output is So these things are also very non-deterministic and sort of inherently non-deterministic. So you sort of have a choice between, so you can have a low temperature setting, i.e. meaning it's not very creative, and run it like once, or you can actually increase the temperature, i.e. get more randomness, run it many times, you ensemble it, and then kind of average across those draws. And both of those have, advantages and disadvantages. Discuss that a little bit in one of the appendix sections. So that's another choice that you sort of have, is how much sort of uncertainty or creativity you want to throw in the process. But I think a lot of the other details about exactly how you prompt it, what information to include, is really contextual. It really depends on your use case, what you're trying to solve for, and it is iterative. You sort of try something and see whether or not it worked, and see what do I need to do in order to do it. There's another style of training which we didn't even get into in this paper, which is called fine tuning. That's where you like, instead of like trying to jigger and make sure it gets the right answer, you just like tell it the right answer, and you're like, learn it, and in the future, get it right. So that's something else that can be, we didn't do it, but that's something that can be tried if none of your iterative improvements seem to be working out.
Thank you. Any more questions? Yes, please, Edgar.
Yes, sorry. So, hello. Let me introduce myself. I'm Eric Menes. I'm working at the PSL University, and I'm working on my subject is lobbying, but we're using NLP techniques and fine-tuning models in order to classify text. And I was wondering why you didn't decide to go for a fine-tuning, because as you said, you already classified some of your data set, so you had like a golden data set that could allow you to then do your classifications, which I mean, I don't know, but most of research articles said that when the texts are too complex, fine-tuning it still outperforms LLMs. And the other following question is, have you tried zero shot? And has it, and does it changes a lot or not with the results?
So I mean, zero shot, in this case would be doing it with any of the prompting or other innovation, just right, just sort of like, like try to. That's sort of what we started with. We sort of started by saying, what do we get if we just sort of throw it and don't provide a lot of background or information or things like that. And it was, wasn't perfect. It got something right, some things didn't, and then we improved from there. We didn't go for the fine tuning step for two reasons, basically. One is that we're sort of happy enough with the accuracy that we got even without a fine-tuning approach. But the other one, maybe a little more subtle, is that the downside of our validation sample is it's all in one state. We have actually done additional validation outside of that state to make sure there's nothing like geographically compromised. Seems to also work across the country, but we are relying on sort of inherently regional validation sample. And so all the prompting and other changes that we're doing are sort of general, right? They can be, they're applied to how you linguistically understand a particular question or corpus that could be applied anywhere in the country. But we were worried that if we like really did fine tune it towards a set of municipalities that for now we only have in one state, that would lead to some degree of overfitting on that set of geographical characteristics. And so we'd be less confident about the external generalizability outside of that one state. Now, if we built a larger sample that was more geographically, or across different urban areas, et cetera, more representative, then I'd be a lot more comfortable applying that fine-tuning methodology.
Didn't you have any problems with the reproducibility of your results, since LLMs tend to change a little bit of the responses?
Yeah, for sure. And so, and like I mentioned, there are two basic things that we had explored in that dimension. One is, just keeping the temperature low, running it once, just kind of calling it a day with that, versus running it many times and averaging across those draws. So the hope there is that it's less going to be less variable if I'm already drawing it multiple times. And so there are different things that can be tried to play around with that, but it's just, for better or worse, it is an inherent aspect of it. It's not completely reproducible. And for that matter, human classifications of regulation are also not inherently reproducible, because getting another person to classify the regulation also isn't going to give you the same answer necessarily. Even the same person on the same regulation another time isn't necessarily going to give you the same answer either. So it is a limitation that matters more for some contexts than others. I think for an academic who wants to run some regressions with this data, you're already willing to tolerate a certain degree of error in your data in the first place. There's probably room for some more inference and thinking about how big the error is and how likely it is to affect any of the conclusions you draw. But I think certainly for people that want a little bit more actionable takeaways for this type of stuff, that last mile seems like a real killer. How do you really get to a fully accurate, fully reproducible every time regulatory data set? That's a very active area of research.
Okay, we're 2 minutes away of our time. David, would you like to ask anything, or shall we close the session? Okay. So, Arpit, thank you very much for taking the time and being with us today. It was a fascinating talk. The video will be uploaded into YouTube, and we'll be happy to have more participation, of course. And our next webinar will be next week. We'll publish it soon. Until then, we wish you a nice day or happy evening, and we'll hopefully see you next week. Thank you.
Thank you so much.
Thank you all very much.
Thanks very much.